Watching this video at home, you want to pause it right here and capture these steps. We're going to show you these steps now in an example where we're going to start with a balanced equation for making titanium. Titanium is amazing stuff. If you have something, do any of you have anything made out of titanium out there? I have titanium cookware for backpacking. Okay. Anybody have a titanium hip joint? No? A little young for that? This clan is a little young for that? Okay. So, I'm going to see if I can move this out of the way. And here, ladies and gentlemen, is our problem. So now you need to start by writing the balanced chemical equation. You don't need to write the stem up there, all of the small print. It's here, going to be here in the video, so you can look at it if you want to. But the reaction is this. The reaction is this. Titanium chloride is reacted at high temperature with magnesium. Thank you for making me unfreeze the screen for the class. There we go. Good, it's unfrozen now. You need to write this equation in your notes because this is the basis of what we are doing. So we take titanium chloride. Under high temperature, we combine it with magnesium, and it makes this metal that's tough, resistant to heat. That's why it's used in the space industry for a lot of things. And that's what we're interested in. Of course, the other product is magnesium chloride, and that's going to be a waste product for us in this equation. Now, up here in the stem that you don't need to write down, we're going to write it down here, is that 1,000 grams, that's 1 kilogram, 1,000 grams of titanium tetrachloride. I would just call it titanium 4-chloride. The place I copied and pasted this from used the kind of the wrong naming system. 200 grams of magnesium, and the question mark is here. So here's the deal. I'm going to change one little thing. It's not going to change anything in your notes. I'm going to write, hello, oh, Leah, more ice bottles coming in. No, we don't need the lid. We don't need the lid. Just the bottle. They are excited because, hey, we have enough for one class now. Here in chemistry class, we get excited over little things like ice bottles. I'm being hopeful for starting the lab tomorrow. I'm just changing this to a different color. Now, there's an important reason that I'm doing this in a different color. Why am I doing this in a different color? Because to do this problem, the first, well, it'll become apparent in a while. So, we have done, we've kind of done step one. We're going to convert grams to moles, okay? So, we're going to do 200 grams of magnesium, and we're going to convert it to moles. So this is the first, this is step number 2, right? This is step number 2 in your example. We've got 1 mole of magnesium. I've got to look that up on my periodic table because I don't have magnesium memorized. Uh-oh. Not only that, I don't have a periodic table here handy. You guys look at 1 mole of magnesium. What's the molar mass of magnesium? Yeah, 24.3. And did you guys get 8.2? Be sure you're checking my work out there. Okay. And we have another reactant here. We have to also convert titanium chloride. So we have 1,000 grams of titanium 4 chloride. And we need to know the molar mass of titanium 4 chloride. Let's see, that's 35.45 times 4 plus, where is titanium? 47.87. So that's 189.67. Hopefully you're checking my work out there. That's the molar mass of titanium chloride, titanium 4 chloride. Notice our units in these places are canceling out. So 1,000 divided by 189.67. Oops, I messed that up. I gotta redo it. 1,000 divided by 189.67. I'm still doing something wrong. I'm getting a really incorrect answer. Are you guys getting an answer for this? Okay, 5.27, thank you. And now we come to that step 3 in our notes. And so this is the thing that's going to kind of be new. Here is step 3. For each of these, we're going to compare it to the amount up in the chemical equation, the number of moles needed. So, for the magnesium, there's 1 mole needed in the reaction. Do you see that there's for 1 mole of reaction, for every 1 mole in this reaction, we need 2 moles of magnesium. Where did this 2 come from? This 2 came from, oops, right here. There we go. That's where the 2 came from. The 1 is just, we're doing 1 reaction. We need 2 moles of magnesium. What's 8.23 divided by 2? The RXN is just the reaction. This reaction needs 2 moles of magnesium. So this reaction, that's what this means, is just this reaction. this reaction needs this much magnesium. So 8.23 divided by 2, should I try this in my head? Let's see, equals 4.1 something. 4.1 what? 115? That sounds right. Thank you. And let's do the same thing for the titanium. This is 1 mole of the reaction. I got to get a skinnier pen. Yes. That says RXN. And that just means the reaction. So once again, this just means the reaction. That's what RXN means. This reaction needs 1 mole. 1 mole of this reaction needs 1 mole of titanium 4 chloride. Now, it comes out to 5.27. Now, if you look at your notes, it tells you now which one of these numbers we're going to choose. And the reason for doing this is it very quickly shows us which thing is going to limit how much of the product we can make. Because we can't make the full amount of product because one of these things is going to run out first. The thing that runs out first is the limiting reactant. Now, which one is the limiting reactant? Your notes have highlighted in blue the least number of moles produced is your limiting reactant. So, the least number of moles produced is this one, which means this is our limiting reactant. So now we're going to use that reactant to calculate how much we think we should make if we start with these two amounts. So we've done some work here, some groundwork, and now we're going to go back and do a stoichiometry problem starting with 200 grams of magnesium. So we're going to do a stoichiometry problem starting with the 200 grams of magnesium. Now you've already done part of this stoichiometry problem. I'm going to rewrite it here, but just remember stoichiometry problems are always grams of something to moles. In this case, it's going to be magnesium to moles of magnesium. And then we're going to go from moles of magnesium to moles of titanium in the equation. And then we're going to go from moles of titanium to grams of titanium. And so, in honor of Mr. Frostad, who wrote this song, I want you to all sing it along with me today. You may have heard me in a video from the Hyatt Hotel or Marriott in Houston singing grams to moles, moles to moles, moles to grams. Grams to moles, moles to moles, moles to grams. It's really, really easy. It's called stoichiometry. Grams to moles, moles to moles, moles to grams. Excellent job out there. So let's do this stoichiometry problem. Now that we've identified which reactant is limiting, we can do the stoichiometry problem. So remember, we're starting with 200 grams. You've already done this, and in reality, you don't have to write this out again. I'm doing it to make it clear that we're starting with, I got to get just a little bit different pen. I don't like this one. Okay, try this. Well, I'm doing this in red because I did this problem here in red, and it's the same problem. I'm feeling shaky because I used my inhaler too many times this morning. 200 grams of magnesium. Let's convert that to moles. 1 mole of magnesium is 24.3 grams of magnesium. Now we're going to use the mole ratio from the balanced chemical equation. And you'll notice that we want moles of magnesium to cancel, right? So we're going to put moles of magnesium on the bottom and moles of titanium on the top. Notice we have the question mark there with titanium. Ti, there we go. So what is that mole ratio that we're going to use? That mole ratio is going to take the 2 from in front of the magnesium and the 1 from in front of the titanium, and it's going to go right there. So the 1, come on pen, 1 from in front of titanium and the 2 from in front of magnesium. Remember, we wanted moles of magnesium to cancel out. That's why we put it on the bottom. So we've gone grams to moles, moles to moles. Now we have to go moles to grams. And this is going to be titanium. We want moles of titanium on the top. Titanium is 189.67. That's the grams of titanium in 1 mole of titanium. So we cancel those out. Remember, we multiply by everything on the top and divide by everything on the bottom. Please check my answer as I calculate this. 200 times 1 divided by 24.3 times 1 divided by 2 times 189.67. The one in green here, or the one right here at the end? That's a 2 because of this 2 right up here. Which come up and point to me which place you have a question mark about.
That one. It only has a 1.
Yes. Yes. Because we want to know the mass of 1 mole of titanium. If we put a 2 there, we'd have to use 48.6.
Okay, but they still cancel out.
They would. But it's the algorithm we use just has us put a 1 there. Oh, I put the wrong, you are right. Okay, sorry about that. Titanium, 47. I had titanium tetrachloride, 47.87. So please change that. Did you notice the difference here? I had a wrong molar mass for titanium. So I've got to recalculate my whole thing. 200 times 1 divided by 24.3. You guys watching the video already caught that, didn't you? Times 1 divided by 2 times 47.87. Okay, do we have the right number now? Does 196 look okay to everybody? 196.99. 197 is also fine. So that's half our answer, right? That's not the total answer. We've got to have grams of titanium. So that is how limiting reactants work. I'm going to have you not just take my word for it. I'm going to have you watch another video now. The other video will be posted on Google Classroom. And let me get this video stopped.